At this time point, we have been doing things in Jupyter Notebook for a while. We started talking about how to load data files into Python using the pandas library. One thing important for loading and reading data is that we should be aware of the location of your Jupyter Notebook on the local computer and the location of the data file you want to load. As usual, let's open Anaconda Navigator, and we can launch Jupyter Notebook by clicking the launch button in the icon for Jupyter Notebook. And this will direct us to a user interface in the browser that shows us the content of a directory, a folder. This folder is exactly the user's home folder on the computer. For example, I'm using a MacBook. In order to quickly visualize the same folder on your local computer, you can simply open the Finder application, and then you can press a combination of keys, Command, Shift, and H. This will quickly direct you to the current user of the computer's home folder, and we will see that this is exactly the same folder as the one we can visualize in the browser. For example, we have a folder here called Desktop, another folder called Documents. Those two folders will also be there in Jupyter Notebook. We have Desktop, Documents, right? So a quick check will reveal that the folder you see in the browser is exactly the same as the folder of the current user's home directory on your local computer. In order to create a new Jupyter Notebook file, you can click on New and create a notebook. In that case, the notebook will be created in the user's home folder. Usually that can cause a bit of a mess, because as you create more and more Jupyter Notebooks, there will be similar IPyMB files, which is the IPython Jupyter Notebook files in your user's home directory. Something recommended is that you can create a new folder. In the browser, we can do new and then new folder, and then we can create this new folder for our course. Let's say 0712, and that creates the new folder in the user's home directory. Quickly switching to Finder, we can see that exactly the same folder appears in your Finder on your local computer. Then in the browser, we can double click on this folder we have just created, and then we can do new notebook. And we can change the name of the notebook on the top by clicking on the title. By default, it's untitled. Now let's change it to data duplication, which is something we're going to do in a few moments, and rename. And going back to the content of the directory in the browser, we can see we have a new Python notebook file with the name we just came up with. And going back to the local computer, in the home folder, we have a new folder called 0712, and then we also created this new Python notebook file called data duplication. On a Windows computer, things can be done in a very similar way. In order to find the current user of the computer's home directory, usually I will just go to the Start menu and then click on the icon right beneath my username. That will open up the documents folder for me. On the left, I will be able to see the different locations on the local computer. In order to find your user's home directory, you can go to local disk C, and then there's a folder called users, and we will be able to see the username of your account on your computer, and click on that folder. You will be able to see the content of your home folder. If we launch Jupyter Notebook in the browser, by default it shows you the home directory, which will be exactly the same thing as what you can see on your Windows computer. Of course, here I'm using Windows 10. I don't have a Windows 11, but I imagine things will be pretty much the same. If you cannot really find the folder, one thing you can do is to click on the search function of Windows and type in File Explorer, and that will open up the File Explorer on Windows. And then again on the left, you can go to local disk C and users, and then try to find the folder that has the name of your username for your Windows account. And once you create a new folder, let's say 0712, in your user home directory, you can enter that new folder. And let's create a new notebook. We can rename that newly created notebook to data duplication. And you will be able to see that in your home directory, there is a new folder called 0712 we just created. There's also this Jupyter Notebook file we have created. So this again shows that what you do in the browser for Jupyter Notebook will be also doing some operations on your local computer. Now let's read a data file into Python by using this new Jupyter Notebook we have just created. Let's go to I'm-Need-to-Learn, where I have uploaded the data sets we're going to use for in-class examples. Go to Content, and then under the Table of Contents, go to Datasets for in-class examples. This time we're going to use this data file called cells_duplicated. Let's click on the link to download the file. And the file will be downloaded to some default folder on your local computer. One thing I want to do in order to efficiently and quickly load this data file into my Jupyter Notebook is to copy this file and then find the folder that contains the Jupyter Notebook we're working on, and then let's paste this data file into the same directory as the Jupyter Notebook. Now we can go back to the browser, right? In the working directory, which is the directory that contains your Jupyter Notebook file, we can see that this CSV file has appeared. Again, confirming that what we are viewing is exactly a folder on your local computer. If you are using the latest version of Jupyter Notebook, you can double click on the CSV file, and this will give you some idea about the data you have just loaded. As we can see, it's a table structure. So again, we have a data set of a total number of 10 stores, and we have several columns starting from the stores column that contain the ID of the different stores, and then we have the monthly sales from January to April for every single store in this table. One thing special about this data file is that if you look closely, you can find that there are some duplicated records, right? For example, we have 2 store 52, and if you compare the 2 rows, we'll see that for the monthly sales, we have exactly the same numbers for those 2 rows. And this shows that we actually have a duplication, right? We should move one of the rows to reduce the duplicated information. Also, not only this store 52 has a duplicated record, we also have 2 store 71, and a closer examination will reveal that the monthly sales of those 2 rows, row 5 and row 9, again exactly the same monthly sales numbers. So that's another duplicated record. Now let's go to Jupyter Notebook and read this data set into Python. And to do that, we first need to import the pandas library, and we again use the alias pd. Then we can do read underscore CSV. For this function to read a CSV file, we need to provide the file name of the dataset. And we can see from our local folder, now this file is in the same directory as my Jupyter Notebook file. I will just copy the file name. The extension is CSV. After reading this data file, I'm gonna generate a data frame, and I will give a name to the data frame. Let's call it sales underscore DUP, just to remind ourselves that this is a data set with some duplicated records. Now, I also want to quickly view the first few rows of this data frame. So I will do the name of the data frame and then head. As expected, this shows us the first 5 rows of this data set. If you do 10, you will see 10 rows. Now, having this data frame ready, the first thing we want to do is to check if there is any duplications of the rows. And to do that, there's a very simple function called sales dup. That's just the name of the data frame, right? And that function is a method attached to any instance of data frames. So we use dot duplicated, and it returns us a column of Boolean values. For every row, it tells us either false or true. As we can see, there are 2 truths: row number 2 and row number 8, right? And row with number 2, the row with the index 2, is the second row we have store 52, right? The first row is not treated as a duplication because that's the first time we see the record of that store. The second time it shows up, if the content of all columns, all variables are exactly the same as a previous row, it's recognized as a duplication. And same thing for store 71 in row number 8. It has already appeared in row number 4, and the sales numbers for every single column for those two rows 4 and 8 are exactly the same. That's why this function duplicated tells us that row index number 2 and number 8 are two duplicated rows. Now, if we have identified duplicated rows, usually we want to drop the duplications because that's just the redundant information. And to do that, again, let's call on the data frame sales underscore DOP. And this time I'm going to use another function called drop duplicates. This function will help us drop the duplicated rows. Again, by default, this will return a copy of the data frame with the duplications removed. And sometimes we want to just make the changes in the original data frame. To do that, let's do in place equal to true. And then again, let's visualize the content of the data frame after dropping the duplicates by using the head function. Now we can see row number 2 is gone, and row number 8 is also gone. So basically the mission is completed. If we want to make it nicer, a good thing is that we want to reset the index, right? Because now after dropping the duplications, the row indexes are no longer continuous, which may potentially create some confusions in the future when we are trying to do some further analysis. So let's do sales DUP dot reset index. And this will reset index. I will also add drop equal to true because I don't want to keep the current index, which is discontinuous. And if I do that, we can see that index values are continuous again. Of course, if we look at the same data set, we'll find that pretty much things are not changed. Well, it may appear surprising, but we already mentioned why this sort of things happens, right? Because we didn't specify in place equal to true, and because of that, the function returns us a copied instance instead of the original data frame. So let's go back and do it again. This time I have in place equal to true and then show the content of the data set. Well, this time it's actually changed, which is something we desire in this specific situation.